Good morning, students. Today we are going to discuss kinematic equations of motion for a uniformly accelerated body. If the body is accelerating uniformly, then we will use kinematic equations of motion. So, equations of motion can only be applied if the body is moving with uniform acceleration. Okay, kinematic equations of motion can only be applied if the body is moving with uniform acceleration. Now there are three types of kinematic equations. The first one, velocity time relation. Velocity time relation is v equal to u plus at. The second one is position time relation. Position time relation is s is equal to ut plus half at square. And third one is velocity position relation, which is v square minus u square is equal to 2as. So these are the three equations of motion. We can see how to derive this equation using graphical method. So before that, let us see one more topic, relative velocity. So what is meant by relative velocity? Relative velocity means how a first body will observe the motion of the second body when two bodies are moving in different speeds. Okay, suppose two bodies are moving with different speed. So how the first velocity see about the other body, that is called relative velocity. So I am saying like this, relative velocity of object 2 with respect to object 1 is the time rate of change of position of object 2 with that of object 1. So we say like this, relative velocity of A with respect to B. It is given by VAB. Okay, VAB meaning relative velocity of A with respect to B, which is equal to VA minus VB. So what is VAB? How B observes the motion of A, that is called VAB. Similarly, relative velocity of B with respect to A is written as VBA, which is VB minus VA. So VBA meaning how A is observing B. Okay, so let us see the example for the relative velocity, then you will get the clarity. Suppose there are two cars. The first car is moving with a speed of 40 meter per second and the second car is moving with a speed of 60 meter per second. Both the cars are moving with the same speed. Okay, both the vehicles are moving with the same speed. Now I am going to find relative velocity of A with respect to B. VA minus VB. So 40 minus 60, which is minus 20 meter per second. What is the meaning of that? Minus 20 meter per second. What is the meaning of that? It means that when B is moving forward, B will think that A is moving backward with a speed of 20 meter per second. Okay, when B looks at A, B will think that A is moving backward with a speed of 20 meter per second. That is the concept behind relative velocity. Now, what is VBA? Velocity of B with respect to A. VB minus VA. What does this mean? This means that when A looks at B, A will think that B is moving forward with a speed of 20 meter per second. Okay, so that's the idea. Now let us discuss one more example. In this example, I am going to stage two vehicles One is moving like this and another vehicle is coming in the opposite direction. So two vehicles are approaching each other. They are coming in the opposite direction. Then what do we do? If they are in the opposite direction, what you have to see is always the direction of the first body should be taken as positive. And if second body is coming in the opposite direction, its velocity should be taken as negative. Direction of the first body should be taken as positive. Okay, so I am writing VAB, which is VA minus VB. So since the direction of the second body is opposite, I am putting here a negative sign. So VA minus VB, 40 minus 60. That is 100. So second body will think that first body is moving with a speed of 100 meter per second in the forward direction. That means in that direction towards right. Now what is VBA? VB minus VA. So minus 60 minus 40. What does this mean? This means that second body is moving with a speed of 100 meter per second in the backward direction. Not in the backward direction, in the opposite direction as that of the first body. Okay, so A will think that B is approaching A with a speed of 100 meter per second. That is minus 100. So this is the concept of relative velocity. If two bodies are moving in the same direction, if two bodies are moving with the same speed and same direction, then what is the relative velocity? Relative velocity of two bodies will be 0. So I can say this graphically. Just listen. Suppose two bodies are moving with same speed. So I'm just drawing the position time graph. Two bodies are moving with same speed. You can draw the graph as two parallel lines. This is A, this is B. So velocity of A equal to velocity of B. Then the graph is parallel line. Now think like this. So here which is ahead? Which is moving first? A. A is ahead of B. Now look at the second graph. Look at the second graph. In the second graph, I am going to tell you A is traveling with greater speed and B travels slowly. So this is VA, this is VB. So here VA will be greater than VB. So this is the graph. Okay, so when VA greater than VB, the slope of the graph A is more, slope of graph B is less. So that is the second case. Now I will tell you the third case. A is moving slowly. A is moving slowly and B is moving faster than A. So this is velocity of A and this is for the velocity of B. B is moving faster than A. Then what happens? You just see, I just marked that time T1. So A is ahead of B, B is coming behind A, but since the B is moving with a greater speed, at this point of time, at the time T1, B overtakes A. So we can say VB greater than VA, B overtakes A at time T1. Okay, now look at the last graph. Look at the last graph. This is time, this is the speed, then A is moving like this, B is moving like this. Here both of them are approaching each other. That means if A is moving in this direction, B is coming in the opposite direction. So both of them are moving in the opposite directions. So that is the graph. And both of them meet. Both of them meet at time t1. Okay. So both are in opposite direction. So that's the graph showing the same. So this is all about the graph about, these are the 4 graphs related to relative velocity. So if relative velocity is same, the graph will be parallel line. Otherwise, depending upon the slope, you can say which one moves faster and which one moves slower. Okay. Now let us see how to derive kinematic equations of motion using graphical method. For that, first we need a velocity time graph. So I am going to draw the velocity time graph. Look at the graph. When the body is moving in a straight line, the graph is a graph is a straight line. If the body is moving with uniform acceleration in a straight line, the graph will be as shown by the blue arrow. This is the initial velocity u, this is the final velocity v. We can do like this. This is u and this full is v, and then this CD will be v minus u. That's a graph. Now, how will I derive the equations of motion? So, let us go to the first equations of motion, that is velocity time relation. So, v is equal to u plus at. This is what we are going to derive first. For that, I am going to find the slope of the graph. Slope of the velocity time graph gives the acceleration. So, slope gives acceleration. So, I will write A equal to, take the triangle ADC. Take the triangle ADC and find tan theta. Slope meaning tan theta. So, take the triangle ADC and find tan theta. So, tan theta is equal to CD by AD. And what is CD? V minus U. What is AD? T. So V minus U is equal to AT, or V is equal to U plus AT. This is the first equation. So first equation of motion is derived by finding the slope of the graph. So you can take down. Now let us see second equation of motion. So what is second equation of motion? S is equal to ut plus half at square. We have to derive this. For that, I will find area under the graph. Area under the graph gives displacement. Area under the graph gives displacement. So we are going to find the area of trapezium OACE. Area of trapezium OACE. So I am writing like this. Area of the graph gives displacement. So I will write displacement equal to area of triangle CAD plus area of rectangle OADE. So area of triangle plus area of rectangle will give you the area of the trapezium. Now let us use the usual formulas for area of triangle and area of rectangle. Okay. So S is equal to area of triangle is half BH, and the B is this and H is this. So half into V minus U into T. Okay. Half BH. B means AD and H means this. So half into V minus U into T plus area of rectangle is L into B. L means OE and T means AO. So L into B can be written as U into T. Okay, L into B is written as U into T. So UT. Now we have already studied from the first derivation that V minus U equal to AT. So instead of V minus U, I am writing AT. This I got it from the first equation, first derivation. So V minus U equal to AT. So half AT into T plus UT. This can be written as S is equal to half AT square plus UT, or S is equal to UT plus half AT square. So this is the second equation of motion. Take it down. All those equations of motions we are deriving all three equations of motion using the same graph itself. Now let us move on to the third equation. Third equation is V square minus U square is equal to 2AS. This is the third equation. Again we are going to find the area under the graph, because area under the graph gives displacement. But here we cannot include time. So we are making the equation without the time. Okay. So I am taking the area of the trapezium directly. So I will write like this. S is equal to area of trapezium OACE. Area of trapezium OACE. Okay. Now, what is the equation for area of the trapezium? Half H into A plus B. That means half into sum of the parallel sides into the perpendicular distance between the parallel sides. So I am just writing like this. S is equal to half into sum of parallel sides. That means CE plus OA. Those are the two parallel sides into distance between the two parallel sides. That means OE. So this is the equation for the trapezium. Now you can tell me what are all these letters represents. So what is CE? CE is marked as V, right? So V plus OA is U and OE is written as T. From our first derivation, we know V minus U is equal to AT. So what is T? V minus U by A. So we will put that here. Instead of T, we will put it here. So I will get S is equal to half V plus U into, instead of T, I will put V minus U by A. Now can you tell me what is V plus U into V minus U? Yes, V square minus U square. Therefore, I will write S is equal to V square minus U square divided by 2A. Now I can just rearrange it. That means take 2A to the LHS. Therefore, I will get the final answer as 2AS is equal to V square minus U square. 2AS is equal to V square minus U square. That is our third expression. Okay, like this we can derive all the three equations of motion using graphical method. Okay, thank you.